All right, let's briefly take a look at the chemical reaction equilibrium. Some chemical reactions cannot go to completion and reversible. Those reactions are reversible. Reactants and products in those reactions are virtually reach equilibrium. At equilibrium, the rate of process from reactants to products, the forward process, equals the rate of process from products to reactants, the backward process. Because the net concentrations of the reactants and the products do not change at equilibrium, they are used to define the equilibrium constant. The constant is a characteristic value for given reaction for given temperature. And this is chemical equation, general chemical equation. You can take a look at here. The capital A, capital B are reactants. Capital C, capital D are products. The small a, b, c, d are called coefficients. Okay, take a look at the equation for the constant, for the equilibrium constant. All right. This is the fraction expression. The numerator. Let's take a look at the numerator. This is products in numerator, and the denominator is the reactants, and the C concentration. It is square bracket stands for molar concentration. Okay, and reactant C to the order of small c. Small c is a mole number, and multiplied by the concentration of D product to the order of small d. D is the mole number of D product. Okay, on the denominator, okay, in this fraction, the A and the B are reactants. The concentration of A reactants to the order of A, small a, the number of mole of A reactants multiplied by concentration of B to the order of small b. Okay, small b is the mole number of B reactants. Okay, that's the expression of equilibrium constant. Okay, let's take a look at this relationship here. If the constant larger than 1, the products larger than reactants, the concentration of products larger than the concentration of reactants, the reaction favors the products. Okay, this is called exothermic. The delta H is a minus. Okay, if the K smaller than 1, concentration of products smaller than reactants, the reaction forward reactants, okay, backward, this is called endothermic process. The delta H is a enthalpy change is a plus. Okay, if the K equal 1, the concentration of products equal concentration of reactants, the reactions favor neither products nor reactants. The enthalpy change is 0. Okay.